Okay, first step, very straightforward, simple equation. X plus 7 equals 10. We all know the answer is 3, but we need the techniques which will get us to the answer 3. I'm just going to show you this. If I gave you a sum 2 plus 5 equals 7, then I hope that you can see I could write down another sum which is equally true, made up from those same numbers underneath. I could leave the 2 on the left, that's the centre, this is the left, this is the right. I could leave the 2 where it is on the left, and I could write the sum like so instead. 2 equals 7, take away 5. What you can see is that the plus 5 has really been taken to the other side, and it changes to the opposite sign, a take away 5. I'm not explaining why it works. Your teachers may have talked about a process called a balancing technique. All I'm saying is it does work, and it works with algebra as well. So if I go back to here, I'm going to leave the x where it is on the left, just like I left the 2 on the left. This is the left, this is the right. And I'm going to leave the 10 where it is on the right hand side of the equal sign, just like I left the 7 there. And I'm going to take that plus 7 and I'm going to shift it to the other side, just like I shifted the plus 5 to the other side to make it minus 5. So I make that plus 7 becomes minus 7. And we get that statement coming out, that x must be the same as 10 take away 7. Underneath I'm going to leave the x exactly where it is, equals, and work out 10 take away 7. And the answer is 3. That's it. Simple as that. Okay, let's do another one. Number 2. Get rid of this. So number 2. How about x take away 4 equals 9? Well, let's give you an example of a sum very similar to it. We could have 10 take away 1 is equal to 9. I could rewrite that sum in a different way. I could leave the 10 where it is, equals, the 9 I could leave exactly the same, and I could take that minus 1 from the left hand side of that sum to the right hand side of the equal sign of that sum. And if you take it over to the other side, you just change it to the opposite, it becomes a plus 1. And there you get another true statement. 10 is the same as 9 plus 1. That's a true statement, so you're allowed to do it. In the same way, leave the x on the left, just like the 10 was left, equals, leave the 9 where it is on the right, like I did last time. And the minus 4, take it to the other side, minus 1 became a plus 1. Minus 4 becomes a plus 4. So you get x is equal to 9 plus 4. That is a true statement. If x take away 4 equals 9, then it is true to say that x is the same as 9 plus 4. That is a true statement. And now you can say, so that means that x must be equal to 13. Easy. A couple more. Okay, number 3. How about 8 is equal to x plus 2? Subtle difference in this. Obviously it's still easy to do in your head. We know the answer is 6. But how do you get to the answer 6? By a routine, a set process. Well, this time you can see you've got the equal sign there. You've got the number 8 on its own on the left hand side, and you've got the x plus 2 on the right hand side. Well, my little hint to you would be, if the x appears on the right hand side in the question, keep it on the right hand side in your answer. If x appears on the left hand side, keep it on the left hand side, like it was in questions 1 and 2. So, in this particular case, let's have our sum to show you the same sort of things. 7 equals 4 plus 3. That's a similar setup to the equation. We could rewrite this sum in a different way. I could leave the 7 where it is on the left hand side. I could take that plus 3 to the other side, and if you change it to the other side it's a minus 3. And you leave the 4 where it is on the right. So, if 7 is 4 plus 3 is a true statement, is it true to say that 7 take away 3 equals 4? Yes it is, so you're allowed to do that. Once again I've taken a number over to the other side and changed its sign. So I'm going to do the same thing here. I'm going to leave the x where it is. That's similar to leaving the 4 where it is in the sum. And I'm going to leave the 8 on the left, exactly where it is, similar to where I left the 7 where it is. And I'm going to take the plus 2 to the other side, just as I took the plus 3 to the other side, and it became a minus 3, and the plus 2 will become a minus 2. So if I have 8 equals x plus 2 as my starting equation, then 8 take away 2 equals x, is perfectly true for that situation. So on the left, 8 take away 2, work it out, is 6 is equal to x. So 6 is x, which of course is what you did in your head 5 minutes ago. Okay, last one, with this very basic first step. Okay, so we'll have number 4. How about 9 equals x take away 5? Okay, similar sum, 8 equals 10 take away 2 is similar to that setup. That's the same sort of setup. Different numbers, but it's the same sort of principle. Well, that's a true statement. I can get an alternative true statement by simply taking that minus 2 to the other side and it becomes a plus 2. So you get 8 stays there, minus 2 becomes a plus 2 and leave the 10 on the right. So there's an alternative statement which is also true as was that starting statement. So do the same thing here. Okay, leave the x where it is on the right, it starts on the right, so leave it on the right. That minus 5, take it to the other side, the minus 5 on the other side becomes plus 5. So you get 9 plus 5 on the left hand side. So if that's a true statement, that must be a true statement as well. 9 plus 5 is 14 and that's equal to x. And it's as simple as that. I haven't explained why it works, I've just demonstrated with some easy sums it actually working like that. I haven't talked about the balancing technique, I've just done the basic principle for step 1, short and sweet. That's the end of this video.